Welcome back everybody to your 15-minute science lessons, the free online learning to support you with your science GCSE. Thank you to everyone that has viewed the first video. Today is part 2. We're still looking at the AQA Paper 1 Chemistry Trilogy exam questions. There will be crossover to the separates GCSE and there will also be crossover to other exam boards. So this is Chemistry Part 2. Let's get started. So we have a question this time. It involves some mathematical skills. So like I did before, I'm going to highlight the key information in the question. I'm going to give you the knowledge that you need to access this question successfully, and then we're going to answer it. So the relative formula mass of a group 2 metal carbonate is 197. I've been given some relative atomic masses. Great. If I didn't have them, I could just look on my periodic table. Calculate the relative atomic mass of the group 2 metal in the metal carbonate, and then we've got to name it. Right, where do we start? So the first thing we need to know is what is the carbonate group. So the carbonate group is CO3. So what this question is telling me that I have got an unknown metal with a CO3, and I'm going to call the unknown metal X. And when I add all of the relative atomic masses together, it will give me a total of 197. So I'm just going to do some process of elimination. So if I just want to get X by itself, and that's what I need first, I'm going to calculate the relative atomic mass of the CO3. And I'm going to do that by carbon. I've got one of them, so that's 12. And oxygen, I've got 3 of them, so that is 48. And I'm going to add those two together to give me 60. So the relative atomic mass of the unknown metal, which I've just called X, just so you can clearly see what I'm working out, is 197 minus 60. 137. So I've done that bit. I've calculated the relative atomic mass. Before we go on and identify the metal, let's just add a bit of information here. So relative atomic mass, found as the top number on the periodic table, it is an important definition that we need to know. Relative atomic mass is the average mass of one atom of the element compared to 1/12 of an atom of carbon-12. Bit of a mouthful, but there'll be 2 marks if this definition comes up. The first mark is for saying it's the average mass of one atom of the element, and the second part for saying what it is compared to that 1/12 of carbon-12. 1/12 of 12 is 1, so comparing it really to 1. So now, if we go back to the question, I've worked out that the average mass of one atom of this metal in group 2 is 137. Well, how do I identify it? I go to what is going to be my absolute hero in any exam, my periodic table. So I'm going to go to group 2 because the question's told me that. It's not even left it that open. So I'm looking at group 2. I'm looking for a relative atomic mass. If I didn't know which number that is, I can use the key here. The relative atomic mass is the top number. Fantastic. I have got one that matches 137. If I didn't, I'd need to go back and check my calculation. But luckily it does match, and it is barium. So we've calculated the relative atomic mass and we have identified it as barium. Brilliant. Let's look at our next question. The reaction between sodium and chlorine is exothermic. Complete the reaction profile for the reaction between sodium and chlorine. Right, okay. Well, let's find out a little bit about exothermic. So again, in a definition that we need to know. So exothermic, energy is released to the surroundings. So energy goes from the reactants to the surroundings. Now, how do you know if a reaction is exothermic? It's indicated by a temperature increase. So we need to show a reaction profile where the energy has been released to the surroundings. If you release energy to the surroundings, then you're going to have less energy at the end because that energy has been given out to those surroundings. So reaction profiles, if we just put a bit of information. So there's 2 lines on a reaction profile, one for reactants, one for products. You will also have sometimes activation energy labelled on it. Now this one doesn't say to label it, but a lot of the time it is a follow-up question, or it is part of the actual question itself to label the activation energy. And the other key bit is the overall energy change. We need to know where that is as well. So we'll just start by doing what the question is asking, and then I'll put that extra information as well. So reactants to products, so it's exothermic, so I know I've got less energy in the end. So the line for the products is going to be lower down on the y-axis because it's got less energy, but it's going to be further along on the x-axis because in a reaction your products come later. You start with the reactants here, so your products are later in the reaction. Reactants turn into products, and the products you can see here, this is how much, I'll do it in a highlighter, this is how much energy is in the reactants, this is roughly how much energy is in the products, so you can see it's much less. And when we are joining these together, it's a curve up and then curve down to meet the product line. Now, like I said, this question doesn't tell you to label it, but it could be a follow-on question. So where are these really 2 important labels? So we've got a label here, so it's from the reactant line to the top of the curve. That is where your activation energy is. The activation energy is the minimum amount of energy needed for a reaction to occur. Again, another really important definition. Minimum amount of energy needed for a reaction to occur. The other label, again, it's the difference between the two, between the reactants and the products. That is called your overall energy change. And that is, in this case, how much energy has been released to the surroundings. If it was endothermic, that would be how much energy is absorbed from the surroundings. On the topic of endo, I'm just going to quickly sketch how that would look different. So this one is your exothermic. In an endo, the labels would be the same. So we've got progress of reaction. Sometimes it's time or course of reaction. It's essentially just the time or the progression of the reaction, and then energy. Now, if it was an endothermic, the difference this time would be if your reactants start here. So in an endothermic, energy is absorbed from the surroundings. If you're absorbing energy, then you've got more energy in the end. So the products would be higher up. The curve goes past and then meets the product line. The activation energy and the overall energy change are in the same place, so I'll match up the colours so you can see. So you've got your reactant line to the top of the curve. Now endothermics do have a much larger activation energy, and then you've got your overall energy change. This time that's how much energy is absorbed from the surroundings. So you'd look about there. But obviously in your exam, you've got a ruler, you've got access to that, so yours can be even better than mine. Next question, so we've got sodium. Sodium's a common theme in these questions. Sodium reacts with chlorine to produce sodium chloride. Describe what happens when sodium reacts with chlorine, and we need to talk about electron transfer. This is, if you actually can pick apart the question, it's some very easy marks that we can be picking up. So electron transfer, it wants us to talk about bonding. Well, which type of bonding do we talk about? So there's the 3 types. When you've got a metal and a non-metal, then the type of bonding you're going to talk about is ionic. The key word for ionic is transfer of electrons. So there's a bit of a hint really in the question that it's asking you to talk about electron transfer. It's pretty much told you that it's ionic bonding that you should be talking about. If you've only got two or more non-metals, then it is covalent. The key word for covalent is it's a sharing of electrons. They don't move from one atom to another. They're shared between the outer shell of more than one atom. And if you only have a metal, then that is metallic. So actually, this question's been really nice. And that one, is where we have delocalised electrons. I'll just finish this so I don't jump ahead and we can all follow where I'm going. So metal only, delocalised. Now this question, again, has hinted to what you should be answering. It tells you electron transfer. Now before we can talk about the electronic transfer, we need to know the electronic structure. So sodium, 11 electrons, that's the bottom number, the atomic number. Chlorine, 17 electrons. I'm not going to draw them, I'm just going to write them. So sodium would split into 2 on the first, 8 on the second, 1 on the third. Chlorine would be 2, 8 and 7. So transfer of electrons, so in ionic bonding, the electrons move from the metal to the non-metal. So we can see this is a straightforward transfer. 1 electron will move from sodium to chlorine. Because the sodium loses 1 electron, it becomes positive, a positive charged ion. And because the chlorine gains 1 electron, it becomes a negative charged ion. I'm going to just do a quick demonstration as to why, because this is the bit that people might find or sometimes don't understand why. If you lose an electron, do you become positive? So if we remember, I'm just going to do protons and electrons. So an atom has no charge because it has the same number of protons and electrons. So if you had 3 protons, 3 electrons, you'd have no overall charge. The 3 pluses will be cancelled out by the 3 minuses. If you lose an electron, and I'll show you by just using the rubber, you can see that now I have a proton that is no longer being cancelled out. So when you lose an electron, you become positive. If I gain an electron, and I'll use the same number as above, so if I gain an electron this time, there is no proton to cancel that electron out. So if you gain electrons, you become negative. How do we put this into an answer? Exactly what we've just said. So we've got the knowledge that we need to access it. It's no more difficult than that. It's not even you need more of one than the other. It's a 1-to-1 ratio. The amount of electrons that sodium wants to lose is the exact number that chlorine wants to gain. So sodium transfers 1 electron to chlorine, and it's definitely a good idea to always put the number of electrons. Don't just assume that the marker knows how many that you're talking about. Sodium transfers 1 electron to chlorine. Sodium becomes a positive ion. So ions are what we call charged particles. So atoms don't have a charge because they have the same number of protons and electrons like we just demonstrated. If they do have a charge, they're no longer an atom, they are an ion. An ion is a charged particle. And chlorine is a negative ion. And that would be Cl-1. You could just put minus, just don't have to put the 1. When it is a 1, you can just put the plus or minus. Sometimes tied into this question, again, not here, they could have you link this to oxidation and reduction. So oxidation is the loss of electrons. So sodium is oxidized. Reduction is the gain of electrons. So chlorine is reduced. That's how you may remember the meaning of oxidation and reduction in terms of electrons. Oxidation is the loss, reduction is the gain. And I've seen that tagged on to the end of an ionic bonding question for some extra marks. So fantastic. Thank you again so much for watching this video. I hope you find it useful. Part 3 will be coming soon. Again, all I'm wanting to do is to support you with your science GCSE. Thank you so much, and please do like the videos if you find them useful, and if you want to subscribe, even better. Bye guys.